sugar. Oh, honey, honey.
I'm Elizabeth Kitching, and I'm doing the caramelization of sugar and the difference between fructose, sucrose, and glucose.
I'm Emily, and I'm talking about physical versus chemical changes in sugar and sugar as an explosive.
I'm Brittany, and I'm going to be talking about how sugar affects the body and the Lewis dot structure of sugar.
Go.
And hello world, I am Prince Monosaccharide the 67th. I belong to the sugar bear tribe.
Caramelization is the heating up of solid sugar. It leads to the flavor of bakery goods, coffee, beverages, beer, and peanuts. Caramelization starts at relatively high temperatures as compared to other browning reactions and depends on the type of sugar. Caramelization occurs during heating and roasting of foods that have high concentration of carbohydrates. Simply speaking, caramelization is the process of removal of water from a sugar followed by isomerization and polymerization steps. In reality, the caramelization process is a complex series of chemical reactions. The first step is the melting of sugar at high temperatures, followed by the foaming or boiling step, which decomposes glucose and fructose. The third step, the condensation step, is the step in which the sugars lose water and react with each other. Then the isomerization step changes aldose to ketose, and the last step is the fragmentation reactions and polymerization reactions. Glucose is a simple monosaccharide found in plants. It is absorbed directly into the bloodstream during digestion. Cells use it as the primary source of energy and a metabolic intermediate. Glucose is one of the main products of photosynthesis and fuels the process of cellular respiration. Fructose is a simple monosaccharide found in many plants, which is also similar to sucrose. It is absorbed directly into the bloodstream during digestion. Pure dry fructose is very sweet, white, odorless, crystalline solid and is the most water-soluble of all sugars. From plant sources, fructose is found in honey, tree and vine fruits, flowers, berries, and most root vegetables. In plants, fructose may be present as the monosaccharide or as a molecular component of sucrose, which is a disaccharide. Sucrose is the organic compound commonly known as table sugar and sometimes called saccharose. A white, odorless crystalline powder with a sweet taste, it is best known for its nutritional role. The molecule is a disaccharide composed of the monosaccharides glucose and fructose with the molecular formula C12H22O11.
So, when we're cooking with sugar, it undergoes a few chemical and physical changes. Before we discuss that, though, we need to discuss the basics of physical versus chemical changes. So when we have a physical change, there's a change of state or substance, but the chemical composition stays exactly the same. Like when you melt an ice cube and turn it into a liquid, solid water is still H2O, but when it's liquid formation, like this, it's still the same chemical compound, H2O, or water. A chemical change is when you're changing something and you're changing the chemical composition of this. So if I were to burn a piece of wood, this is a chemical change because when we are burning the wood, it changes into a different chemical form. How to tell the difference between them? A chemical change will have a chemical reaction forming, and when you're trying to tell the difference between a chemical and physical change, you have to look for a few things. A heat formation, a precipitate formation, change of color, or any other things you know that happen during a chemical reaction. So when we're cooking with sugar, it undergoes a few chemical and physical changes. such as when we're making cookies, it's a chemical change because we're mixing sugar in with other ingredients to bake cookies, and you can't just break apart this cookie and dig out the individual sugar particles. That won't happen. But also another chemical change is when you're heating up sugar to make caramel or toffee, it starts formation like a solid brown color, and you can't change it back into sucrose. Okay, so sugar undergoes a physical change when we mix it in water, because when we scoop out some sugar and we pour it into the water, we stir it in, and a chemical reaction doesn't happen because we can dehydrate the water and we will get the solid sucrose, a form of sugar, back, and we'll be able to use it to make cookies or something. It'll be the same chemical composition. What if, with a sprinkle of sugar, a disturbance of that layer, and with the light of a match, I could light a room or a building on fire and explode it? So, sugar can be used as an explosive, and a lot of people don't know that. Sugar has exploded in a refinery. For example, in 2008 in Georgia, there was an explosion that happened where the sugar refinery exploded in the primary and secondary reactions because there was sugar particles laying around, and it got too hot, and lo and behold, the factory exploded. 20 workers were injured, and 17 were put in medically induced comas. So how does this happen? Well, first, there are a few prerequisites that have to happen. First, it must be an enclosed room with everything sealed off, and there must be a thick layer of sugar dust, and the particles of sugar, they have to be clumped up to the size of at least table salt. And there must be a fire source, and there must be a disturbance in that layer. So if I were like to swipe my hand again and light big chunks of sugar on fire, this could create an explosion. So there's a chain reaction for how this explosion happens. There's a first and foremost primary explosion that happens. So we'll call that part the boom. And then after that, it triggers a secondary explosion, and we'll call this part the kaboom. So when sugar explodes, it goes something like this: boom, kaboom.
Now that Elizabeth has told us what glucose, sucrose, and fructose are, I think it's time that we dig a little bit deeper into it and discover the organic chemistry behind it. There are different ways to draw the Lewis dot structure for C12H22O11, which is sugar. Our job right now, my job right now, is to show you how to take all these jumble of letters and make them so they make sense in a Lewis dot structure. This is the first way to draw sugar. This is the way it is often found in books, but in real life it actually makes a hexagon shape. This is the second way to draw sugar. This is the way it is found in real life circumstances, unlike that first drawing. You may be wondering why there's only one C in this whole structure. That is because the C's are there, but they are just hidden. They in each of the corners, like here, here, there, there, and there. The C's are there, but if they were drawn in, it would make the structure look much more confusing. This is what it looks like with all of the C's in there. So each time, if you ever take organic, you see something like that where it's denting, it means that there is a C that's there, but just unshown. This is the third and most complex way to show sugar. This also has the similar hexagon shape because it has 1, 2, 3, 4, 5, 6 sides, but it's more confusing looking than the original, which was way 2.
Sugar is loved by millions around the world. Dr. Melanie Greenberg wrote that part of our bodies like sugar and part of our bodies don't like sugar. This becomes very obvious when you think about sinking your teeth into that amazing donut, or when you take the first bite of your mom's homemade chocolate cake. This part of our body tells us it's totally amazing, but this part of our body begs to differ. People love sugar because it's easy to come by in stores, restaurants, and even school places like the cafeteria or vending machines. And they also love it because it's a way to relieve stress, and it also provides energy quickly. But sugar has some negative implications when it's eaten in excess. The average American eats over 156 pounds of sugar per year, and studies show that it can lead to high cholesterol levels. It can also block arteries and help spread cancer. It also leads to diseases like diabetes. Arteries are becoming blocked because obese people have all the pressure from the fats pushing onto their body and vital organs. It also has been debated whether or not sugar is addictive. PH Melanie Greenberg also explains how neuroscientists have found that some people respond to sugar in the same way that people respond to cocaine or heroin. Also, researcher for a national drug abuse company, Nora Volker, has studied that brainwaves are similar between obese people and people who are alcoholics. Don't get me wrong, sugar is definitely a good thing, and it's even essential for human life. We have lipids, which are made by sugars, and they do three things. They help cushion vital organs, so in case we get hit, we won't die immediately. And they also help provide energy, and they serve as insulation. Sugar is very important for the body. Just too much of it is a bad thing.
Since this technically is a final, we wanted to give you guys one question. If you guys can balance this, then you guys will get a sugar cookie. You are allowed to work with a partner, and we'll give you 15 seconds to answer this, and then you'll get a hint. One of the product's coefficients is 11. That is the hint. Prince monosaccharide has solved the equation. The answers are 1, 12, 12, 11. If you got this answer correct, good job. And if you didn't, hurry up and change it before anyone notices. You still get a cookie.